My name is Walter Unglob, and this is solar panel physics. In solar panel physics, we have some light source, such as the sun, and a solar panel here, and the sun will radiate all sorts of electromagnetic radiation. The energy of this radiation, or of the photons, if we look at the quantum limit, is given by the expression E, in terms of the frequency of the light, is equal to Planck's constant h times the frequency nu. Or in terms of the wavelength, because the speed of light is the same for all the particles, we have the energy in terms of the wavelength lambda is equal to hc over lambda, where h again is Planck's constant and c is the speed of light. Lambda is the wavelength of the photons. Now in solar panel physics, the material that the solar panels are made of varies. So we have usually some metal contact at the bottom here, some metal contacts up top, and we'll essentially have two different types of materials: N-type materials and P-type materials. N-type is a type of material, a semiconductor, that has been doped with atoms that have more electrons than the surrounding ones. Conversely, P-type materials are positively doped materials. Now, the physics of a solar panel relies on what Albert Einstein gained a Nobel Prize for in the early 20th century, and that is the photoelectric effect. So the photoelectric effect relies on this idea that the quanta of light, these photons, these small packets of energy, can be treated as particles that can knock electrons off of atoms. So you'll have an incoming photon and an atom inside of your material with electrons that orbit that atom, and the photon will come in with enough energy to knock one of those electrons loose. When this happens, the negative charged particle will go towards the p-type material, so you'll be generating what's called an electron-hole pair every time a photon knocks one of these negatively charged particles off. When you do this, because of this gradient, you'll have an electric field. This electric field will cause charge to flow in a particular direction. And when you have charge flowing, you can generate a current. So when you have large solar panels and a lot of photons coming in and knocking those electrons off, you can generate a good amount of current that you can use to power or act as a generator for all sorts of electrical equipment. My name is Walter Unglob, and this is Solar Panel Physics.